The 2016 Hang Lung Mathematics Awards are governed by two committees. They are the Steering Committee, which is an advisory body that oversees the operation of the competition, and the Scientific Committee, which is the academic and adjudicating body. May I now invite Professor Sir James Mirrlees, Chairman of the 2016 Hang Lung Mathematics Awards Steering Committee and 1996 Nobel Laureate in Economics, to come on stage to say a few words. Professor Mirrlees, please.
Ladies and gentlemen, it's always a privilege of me to get up on these occasions, although I missed the last one, unfortunately, because I think this is a very wonderful competition. Mathematics is a very curious activity. What is it that mathematicians are trying to achieve? I jotted down, I thought there'd be a couple of properties that you want to achieve when you do mathematics. But my list began to get surprisingly long. So in the first place, you generate something that's true. And any philosopher will tell you that's an extremely difficult thing to do. And mathematicians have this magic wand that they can find truths. And don't think that doesn't matter. I think that is a very special respect for something that's out there. It's not a subjective creation. But once you've done it, it's there, and it's nothing to do with you. It's a truth. But when you value the work that people have done, like these remarkable teams of mathematicians from the schools of Hong Kong, there are other properties that the adjudicators, let's call them, the prize givers, have to look for. So the work should be difficult. So not only true, but it should have been something of a struggle to get there. When I was interested that when Ronnie Chan mentioned difficulty, as he did, or maybe it wasn't Ronnie, I think it was Yao Xingtung, in fact. He linked it with depth. And that's the word that mathematicians like to use when they're picking out something that was an achievement, that you're not sure you could do it yourself, which is the basic criterion for what you're looking for. And but this by no means gives you the full range, because you've heard the term a beautiful mind. Beauty is certainly something that you want to achieve when you do mathematics. The beauty might be in the result, the final conclusion, or it might be in how you get there. It seemed to me also that you're looking for something that's surprising. The element of surprise is not essential for good mathematics, but it's certainly part of what's there. And that brings in the thought, should it be useful as well? Yes, that's not a disadvantage. But it's inevitably not something that mathematicians can look for in mathematical work, because it generally takes a little while before usefulness becomes clear. And usefulness means, I mean not just useful for generating more mathematics, but somehow or other that people who don't understand mathematics are going to benefit from it. Now, that point about who understands is an intriguing thought with mathematics, because mathematics is something that you get more pleasure, more fun, more value out of doing it than out of reading it or listening to it. So it's a very active sort of subject. Although you may look back on what you or somebody has done and appreciate it in an aesthetic way, nevertheless, it was an important part of it is the activity rather than just the final results. So although I started by saying these final results being true is wonderful, the getting there is never to be forgotten, and a very difficult thing to convey to people who are not involved. So let me say it's like the difference between playing a piece of music and listening to it. And perhaps most of you have appreciated that particular difference. But usefulness. I'm not exactly sure that the story I will now tell you, it's a true story, is telling you about usefulness, although I think it is. It's a story about a party in Stockholm, a big dinner to celebrate the 100th anniversary of the Nobel Prizes. And on that occasion, 3 people found themselves talking to one another. These 3 people were all from, or had at one stage been at Trinity College, Cambridge, which has already been mentioned, as it happens, this morning. And these 3 people had all got Nobel Prizes. They were all mathematics graduates. The Nobel Prize is not given for mathematics. There are stories and rumors about why not, but at any rate, it's very explicitly excluded from Nobel's will, and there will never be a Nobel Prize in mathematics. However, this was 3 people from one college. There was one missing because, in fact, there have been 4 people from Trinity College, Cambridge, who got the Nobel Prize, but who had been mathematicians initially. One went on to do economics. One went on to do chemistry. One went on to do physics. And Bertrand Russell, who was missing for the most honorable of reasons, had got it for literature. We're still wondering, why didn't we get one for peace? However, the real point of this story is to say not only all the prizes that Ronnie Chan mentioned in his introduction are available, but if you've done mathematics, it can be very useful in other fields as well. And look where it can get you. So my congratulations. We're going to hear some exciting results that people have achieved. And unfortunately, all you're going to see is the faces of the people who've done it. But it's what was going on behind the faces that's great. But you maybe think you can't understand, but you can get some feeling for it, of course. So my warm congratulations to them all, and we all want to know now who got it. Thank you.
Thank you, Professor Mirrlees.